Hi students, welcome to my lectures. We are in the estimation of volume of the liquids and gases for a given pressure and temperature conditions. We have so far covered many things, and we have covered the equation of states for liquids and cubic equation of states to estimate the volume of the liquids and using cubic equation of states. And we have covered the ideal gas method to find out the vapor volumes, virial equations, cubic equations, and generalized equations and generalized correlations. Now we are also into the estimating the kind of estimating the virial coefficients like B and C. B is the second virial coefficient and C is the third virial kind of coefficients, and you can using generalized correlations. You can see that using generalized correlations also you can able to find out these coefficients. That means you can, once you know the coefficients, you can able to estimate the compressibility factor. Thereby you can estimate the volume of the vapors. So this is the method. Let us see this particular method, and later on we try to solve a problem using different methods and compare with that of an ideal gas. Okay, now let us start with finding out the virial coefficients using generalized correlation methods. These are called as Pitzer and Covers. These two came up with some equations to predict the virial equations like B and C. So Pitzer correlations, these are called as Pitzer correlations. The Pitzer and co-worker, they developed a correlations to estimate the value of B and C. That is what's called Pitzer correlations. And there are two things. One is Pitzer correlations for the virial second coefficients and Pitzer correlations for the virial third coefficients. So we start with this and later on take an example using different methods to estimate the compressibility factors and compare with that of an ideal gas. Let us move forward. And using generalized, these are called Pitzer correlation for second virial coefficient and Pitzer correlation for third virial coefficients. And generally we apply these for the gases. And you know the compressibility factor for the ideal gas is PV by RT. In general, Z equal to PV by RT. Z equal to 1 for the ideal gas. And you know, as long as you talk about generalized correlation, the important thing that is come up when you talk about the generalized correlations is TR, PR, and omega. That means whatever the Pitzer correlations they have developed, that means they might have used the reduced temperature and reduced pressure and omega data to calculate the virial coefficients like B and C. If you remember the virial equation like that, Z equal to 1 plus B dash P and C dash P square, or Z equal to 1 plus B by V plus C by V square. So B dash and B can be correlated using B dash equal to B by RT, C dash equal to C minus B square by RT whole square. This kind of, in general, if you talk about the Pitzer, virial equations, Pitzer correlation for finding the virial coefficients. And if you consider only up to two terms, it's called the second virial coefficient expression. If you consider all the three terms, because it's a infinite series, so up to what coefficients you want interested in for the accuracy of the prediction, it becomes virial second coefficient and virial third coefficient. And followed by this kind of equation, Z equal to 1 plus B into P by RT, because if you replace V with RT by P, then because V equal to, if you remember this kind of equations, okay, Z equal to 1 plus BP by RT. That is nothing but 1 plus, if you convert this pressure and temperatures into the critical, reduced temperatures and reduced pressures, that means in place of P, you replace with PR into PC, in place of T, you replace with TR into TC. If you do that, it is going to follow certain step, then Z equal to 1 plus B cap into PR by TR. So you wanted to estimate the compressibility factor in terms of reduced form. So Z equal to 1 plus B cap into PR by TR. What is B cap? Nothing but BPC by RTC. So if you know the B cap, you know the Z. That is what the Pitzer correlation talks about. So Pitzer, a correlation developed some expression for B dash. And if you know the B dash, thereby you can calculate, that's Z. That is what the whole idea. And B dash can be estimated using B naught plus omega into B dash. If you know the B0 and B dash, you can able to estimate the B cap. So if you talk about the B, there are certain expressions and given by the Pitzer to calculate the B0, you have to use this particular expression like 0.083 minus 0.422 by TR power 1.6. To calculate the B dash, 0.139 minus 0.172 divided by TR power 4.2. These both are equations are known as Abbott equations. It's a part of Pitzer correlation. Okay. So if you know the B dot and B dash, you can calculate B cap. If you know the B cap, you can calculate the Z. If you know the Z, you can calculate using this expression the volume. This is what the procedure. And similar Z equal to 1 plus in place of B dash, and you can keep B naught plus omega into P dash because this is the expression proposed through the Pitzer, that you can estimate this particular B cap using B naught plus omega into B dash. So B naught and B dash depends on the reduced temperatures. That means if you know the reduced temperatures of a molecule, you can calculate B0 and B dash. Thereby you can able to apply Z. And if you because B dash is nothing but B naught into omega, but if you expand that, you can 1 plus B naught into PR by TR can be represented in terms of Z naught, and omega B dash PR by TR can be used as a Z dash. If you remember this kind of correlations, it's called a 3-parameter theorem. That means Z can be estimated if you know Z naught and Z dash. And Z naught and Z dash normally people compare with the kind of equation. Therefore, they represent Z naught equal to 1 plus B naught into PR by TR. Z dash is nothing but B dash into PR by TR. So this is one such a form. Okay. Either you go with this kind of equations to estimate the B cap, and second method is if you know the Z naught can be estimated by 1 plus B naught into PR by TR, that is nothing but Z0, or and secondly you can estimate that B dash into PR by TR is nothing but the Z dash. So by calculating Z0 and Z dash and knowing omega, you can calculate Z, or else you can directly use this equation to calculate the Z. It is the same thing. And every equation has the certain applicability of the range, because the correlations are developing up to certain range and molecular interactions are considered. You have to refer to the book that what exactly assumptions made by the Pitzer correlations. So up to what temperatures and pressures these correlations are valid. Okay. It is very now at this point of time you have to only remember that you have to calculate B dash. B dash can be calculated by B0 and B cap can be calculated by B0 and B dash. If you know the B cap, you can calculate the Z. This is the procedure adopted by Pitzer correlation for second virial coefficient. Similarly, you can estimate the Z by considering first 3 terms. Along with B, you have to calculate the C. So Pitzer correlation for the third virial coefficients. So similarly, B naught and B dash can be calculated using this Abbott equations, and similarly if you follow similar kind of method up to considering B dash and C dash also, B cap is representing the second virial coefficient, C cap is considering the third virial coefficient as well. So C cap just like a B cap, C cap can be estimated by C0 plus omega into C dash. What is C0 and C dash? It is given by Orbe and Vera. So they have come up with such an expression that if you know the reduced temperature, then based on this reduced temperature of the molecule, you can calculate C0 and C dash. So B0 and B dash, C0 and C dash, you have once you know the B0 and B dash and C0 and C dash, you can calculate B cap and C cap. Thereby you can calculate the Z through the iteration procedure, because you can see here also it is Z, and here also at the bottom on the right hand side it is Z. So this method is a straightforward. This method you need to do some iterations to get the value of Z using Pitzer correlation for the third virial coefficient. Let us see some examples so that you will get to know the difference. In summary, you can calculate the Z using this particular equation by knowing B naught and B dash. You can use you can calculate the Z for the virial third coefficient by knowing B naught and B dash as well as C naught and C dash. Let us find out some example. Find a molar volume of N-butane at 510 Kelvin and 25 bar using ideal gas equation. So let us do some different things. So you can come, first of all, let us start with ideal gas. Later on, let us go to the estimations of Z using virial second coefficient, third coefficient, and many other methods. So Z can be, that is a compressibility factor can be calculated by PV by RT is equal to 1 for ideal gas. So volume is equal to RT by P. R we know, T and P are given. So molar volume of N-butane at this temperature and pressure conditions of 1696.1 centimeter cube per mole. Example 2, same problem, same temperature and pressures. Now we using compressibility factor correlation. That will be generalized correlation. You know, if you remember my earlier classes, so we have used Z0 and Z dash from the tables. Z0 and Z dash, how you are going to calculate? If you know the TR and PR, so TR is T by TC and PR equal to P by PC. What is temperature? This is given 510 Kelvin, and TC of N-butane is 425.1 Kelvin. So TR is 1.2. Therefore, PR is P. P is given 25 bar, and PC for the N-butane is given as 37.96 bar. So P by PC is 0.659. So you have to locate the point of Z0 at this TR and PR condition and Z dash at this TR and PR conditions. If that is not directly available, using interpolation method, you have to find out the value of Z0 and Z dash. Omega is anyway provided, 0.038, the eccentric factor for N-butane is given. So using this interpolation method, get the values of Z0 and Z dash, which is elaborately discussed in the previous lecture. So once you know the Z0 and Z dash, you apply the formula, calculate the compressibility factor Z using generalized correlations. So this method is the ideal gas volume. This is the calculation of Z. That means Z equal to 1 for ideal gas. So let us calculate the Z and volume for the using this generalized correlation method, the Lee Geissler tables. So using this method, Z0 is equal to 0.865 and Z dash equal to 0.038 and omega equal to 38. If you apply this kind of procedure, you can able to calculate the Z is 0.873. Therefore, the volume of N-butane using generalized correlation method at the temperature 510 Kelvin and 25 bar is 1480.7. Remember, you can see compare with the ideal gas. Ideal gas is 1696 and with the generalized correlation method it is 1480. Now earlier this is the 3 parameter. That is because we are using TR and PR and omega. So this method is a 3 parameter theorem method for the generalized correlation. Let us use only 2 parameter theorem method. Okay, using 2 parameter theorem method, let us solve the same problem of N-butane at the same, then Z nothing but Z0 only. According to 2 parameter theorem model. So Z equal to Py by RT, which is Z0. Therefore, the volume of the N-butane at the given temperature and pressure condition is 1467. Now, let us come to the example 4, what we are discussing, Pitzer correlation for the second virial coefficient and Pitzer correlation for the third virial coefficients. So, if you apply the method of Pitzer correlation for the second virial coefficients, first of all, you should estimate the value of B0 and B dash. So B0 and B dash can be estimated using Abbott equations that is already given. For example, these are the Abbott equation. B0 and B dash can be estimated. So B0 and B dash can be estimated. So if you know the TR, you can calculate the B0 and B dash. Once you know the B0 and B dash, estimate B cap. Once you know the B cap, you can calculate the Z. If you know the Z, you can calculate the volume. So according to the Pitzer correlation for the second virial coefficient, the volume is 1489.1 centimeter cube per mole. And the other one is Pitzer correlation for the third virial coefficients. Along with the B0 and B dash, you should get the data of C0 and C dash. So C0 and C dash can be estimated. As you can observe, these are the equations to estimate the value of C0 and C dash. If you know the TR, you can estimate the C0 and C dash as well. So once you put the value of C0 and C dash, the equation turns up this way: Z equal to 1 minus 0.1208, because substituting everything, 1 minus 0.120 by Z plus 0.0106 by Z square. So this is a equation you are supposed to solve through the iteration method, or directly you put the given, you use an equation solver in the calculator, get the value of the Z. So if you are attempting the iteration method, you have to assume some value. The best possible value for initial guess is assume that the N-butane is an ideal gas. So ideal gas have a compressibility factor which is equal to 1. If you start with the value of 1 and try to iterate and update the value, get the values of Z plus 1, final the solution, that is the compressibility factor Z using the second virial coefficient, is 1485.8. Now you, this is a comparison table. This is what gives the beauty, right? Generalized, let us grant this. let us say equation of state. That means what you are using this different equations of state, finding out the volume. The first equation of state you have used ideal gas. In the ideal gas, the volume we have got is 1696, and generalized correlation using 3-parameter model we have got 1490. Generalized correlation 2-parameter we got 1467, you can see here, and generalized correlation, the Pitzer correlation for the second virial coefficient, and this is a Pitzer correlation for the third virial coefficient, because the basis is generalized correlation, that is why I have given the symbol. So you can see all the values. The ideal gas is estimated very high molar volume. The other equation of states, they estimated lower volumes. When you compare with that of experiments, because everything is an equation may be correct, may be estimated the correct value, and may or may not. So always if you compare the experimental value of N-butane, the molar volume is 1480. Now you see, except an ideal gas, all the other models predicted even at least close to the real value, which is experimental value of the N-butane. So always, that is why it is always dangerous to go with the assumption that everything is an ideal gas. But in reality, you can see that all the other models give a close prediction, whereas the ideal gas model will not give a correct predictions. So in reality, and you have to always consider the non-ideal models. I hope now you have understood. We have gone to the end of the chapter. There is one more small module is left. So let me give a summary. Now we have covered almost all the aspects here. One is PVT estimations, liquids. We have used equation of state, this particular equation of state to estimate the volumes, and we have covered the while in the chapter cubic equation of states, how to estimate vapor volumes as well as the liquid volumes. And this is what the generalized correlation method we will see at the later stage, that in the next maybe lectures or so, we use this generalized correlation method to estimate the volume of the liquids. And we have already covered the ideal gas, virial equation, cubic equation, generalized equations of state, and generalized correlation methods. So we have covered decently the chapter, that whenever you because this particular material, that's a paper, gives overall idea of what we have covered so far. Only one thing is left, I'm going to cover in the next lecture. So now this chapter is almost complete, and now you have got an idea that why there are different methods possible. There are different possible methods are there to estimate the volumes, whether it is for the liquids or the gases. Okay, this chapter is very important, because based on these methods only next chapter is based on. So if you are good at this PVT estimations, the other chapters are not much difficult to understand and apply to calculate the different properties. Okay, let us move on to the next lecture. Thank you.